Hello explorers and welcome to another video. Today we are going to talk about Patroni. And this was something that was really interesting. I needed to create a setup where I had multiple Postgres databases that were clustered, so I can actually have a database that could be up all the time, even though I needed to do maintenance on some services and so on. So I needed to cluster a database pretty much, and I was asking for a simple solution. There is a couple of those built into Postgres, and I tried to figure out how to set them up, and I was talking with one of these many chatbots again, and it came back to Patroni over and over again. So I was pretty much thinking that it was paid off by them to promote it. But it's an open source software and it is pretty good actually. So it's not that bad. The complexity of it is a little bit more than just two servers replicating each other, but I think that complexity might be worth it. So if we switch over to my screen here, I have three different hosts here, and all of them are just simple Debian installs with not that much hard drive space or anything. Nothing extraordinary. I just generated these for this example or this proof of concept, so we can start working on them. They are using Bookworm and no extra packages installed. So the first part we of course do is a sudo apt update to get started here. So we have the latest packages, and it should not be much of an update here. I also will do a write-up that you can find in the description, where you can have all these commands so you don't have to type anything down. Next up, we're going to install a bunch of packages. So we're going to install Postgres, we're going to install the contrib for that package, Patroni, Python, PySync object, HAProxy we'll use, the etc server and client we'll use the etc service, and then we also need the Python dependencies for those in order for them to be used in Patroni, because Patroni is built in Python, so therefore we need those dependencies. And this installing all of the packages will take a little while, so I will get back to you when that is done. And we are done. Now we have installed all the packages, and we can continue by setting a bunch of environment variables. And these are not variables that I need to have every install. I just want to set them up in order to make the process of running the different scripts and creating the different configuration files easier for myself, because sometimes I need to change systems and sometimes I need to change dependencies and so on. So just having these environment variables does things much easier. So first off, we need to have the actual name of this host, so we don't need to have that figured out. We also want to have the IP of this host. We want to have the data dir for our Postgres installation, and these particular places are very Debian specific. So if you're running this on another system, you need to change these, of course. And then we need to have a cluster name. This is a unique name for your cluster and needs to be changed if you have multiple clusters in the same etc cluster. And then we need some variables for the etc cluster. Of course, we need the API version. We're going to run the latest 3. And then we're going to have the etc name. We go with host name there as well. And then we will have the different host IPs here. So a couple of host IPs, and then we will use those for the endpoints environment variable as well. So we can say, okay, I want you to connect to any of these endpoints. So I will copy that off, so we will run that on all the machines. We have those, and of course the variables will differ a little bit depending on the machine. Then we want to set up our configuration in etcd, and we see here that I echo a bunch of things into this etc default etcd. So if we look at what is set here, it's set etcd name to my host name. We get the data directory. It's something that is just set into varlib etcd my cluster. And then we will create this here where we have all the IP addresses with the correct names for them. And then we will have we will create a new state of it. We call it the Patroni cluster. And then we will use the host IP in order to create an advertisement listen, peer listen client, and initial advertisement peer URLs for this cluster. So I will do that on each of these hosts. So we'll have all of those. Now we should be able to start our clusters. I will run system control enabled now, etcd, system restart etcd, and then we will look at the journal in order to see that etcd starts. So we will run that on each of these, and we need to do it fairly quickly because they need to find each other. So if you do this pretty quickly, they will find each other, sync up, and be in a pretty good state pretty quickly. So now we have an etcd cluster, and we can verify this by running this command, etcd control endpoints with our endpoints. We want it to be a table, and we will get a member list. So this is the table of our members, and all of them are started and they have correct addresses and so on. And we can also run this command, which we pretty much looking at the endpoint status here, and here we can see that we have a leader. So number one, the first one is a leader. So that means that we have a cluster that works, and we also have one designated leader in the cluster. So everything seems to be up and running. Next up, we need to do some configuration in Postgres. So we go into PostgreSQL on this first host here, and we'll do something that we will do on all the hosts. So we'll go into Postgres on the other two hosts as well. Okay, so this was the one that I went into, and we will do it on number one as well. So the general configuration we want to do on all of them is setting a password. So the password encryption algorithm should be sham SHA-256, and then we want to set the regular Postgres password to QWERTY in this case. We want to have a replicator user, and we'll set replicator password for that. And we will say that this replicator will also have the role of replication. And we want a rewind user, and we've set just a rewind password for that. These passwords, of course, needs to be changed in a real production environment. But for just testing purposes and proof of concept, it's fine to just have a simple password. So I will create all those in the system. Now I want to create a little bit more, because what my purpose of creating this cluster was to use OpenObserve, and I already have a system with OpenObserve running, so I wanted to migrate that system into this. So in order to keep a database in our cluster, we want to have some data that we can see that that is still there. You could, of course, take this and start Patroni and remove all the database dirs, and it will initialize a system for you, but that is a different use case. So we will do that for host 2 and 3. We will remove the database there, but for 1 we will keep the database, and then it will be migrated to the other 2. So here I want to create a user, OpenObserve, with a password of change me now. And the database OpenObserve, owner OpenObserve, and just a template here. And then a grant usage and create schema for OpenObserve. So I will create those things there. And if we go out here, we should be able to now go with the user local observe to localhost, use the change me now, and we should be in that. With that user, we should be able to switch over to that database, and we'll create a user's database, put in a user, and then select from that user. So now I ran it 2 times, so I got 2 rows here. So now we have some data in our system. Next up, we need to do a configuration for all these. That is for security. What should you be able to do as a user of this system? So we will go into the PGHBA configuration file on all of these. And let's see. I press the one there. Yeah, so need to exit the database, of course. So in this, and we can look at the URL is with etc Postgres 15. So we are running Postgres 15 main and then PGHBA conf. And in that, we have a section here, down here, with a bunch of configurations. But the first configuration line is the first one that will be taken, and then it will go down and see if it doesn't hit the first one, it will take the next one and so on. So I will put some before the last things here. So first off, if you do any local login, we need to do that with the password. Then we can have a local login here where you're coming from localhost as replication. So you want to replicate, and then we will trust that. So you can replicate with a replicate login without any password for this system. And then we also have this replication inside of this particular subnet. So we are using a bnet here, or so 16, so to 192.168 and whatever here should be available to go in. And you can of course set it as large or as small as possible. But in this case, we want to have something that this replicator can connect from the other host and replicate data over to their host. And then if you come from anywhere else, you can log in with a password, of course. So all of it, internet pretty much. So that should be fine as I'm behind the firewall. So this is just for testing anyway. But you need to change those values in your system, of course. So let's put it into host 2. Save that there, and we'll go into, why are all these changed? There we go. So in host 1, we will copy that in as well. So after we've done that, we need to do the Patroni config. So we go to the first one here, and I will run this echo command again, and we'll get a large configuration file. So I will run that on each host here in order to get my configuration across. And then we can check the configuration. So it will be an etcd Patroni config YAML. So first of all, we set the scope here. This is our cluster name. And then we have the name of the actual host here. So we'll just have the host name. And then we will have a REST API that we can connect to in order to talk to this database. And this will be listen on 8008. And you can connect from another host on this REST API as well. And then you have the etcd cluster. So here we say that pretty much to our local host connect to the etcd port. And then we need to bootstrap a database here. So what we will send into the etcd cluster you have over here. So you say that you should have a time to live of 30, you should have a loop weight of 10, a retry timeout of 10. So these are just connection information. And then we have for the Postgres, reviews PG rewind, that should be available. And we needed to create that, that account. In order to do that, we should use slots. And slots is something that is created for the replication in. And then the wall level should be a replica. Hot standby is on. And so we could switch over, much simpler. Wall log hints should be on, or else the replication would fail. Login collector should also be on. And then we'll have a wall size. You can choose how large it should be. But this write ahead log, I say, should be maximum of 10 gigabytes. Should be enough for my use case here. And then we have an initialization of the database that the encoding should be UTF-8 and data checksums should be used. And then we have this HBA configuration again. So if it bootstrap that into our etcd, so that is available. Now comes the Postgres configuration here. And here we have the port it should be listening on, and the connector address it should be connecting from the other host, of course. Then we have turned up the data dir, the bin directory, and the configuration directory. And then we have the authentication here. So here we have the user information and also the passwords for the super user, replication, and rewind. And then we have the parameters for the Unix socket, where should it put the socket configuration files, and the password encryption should be SHA-256. And then we have something called Watchdog. And Watchdog is pretty much something that looks at if the system has hang. So here you could have some kind of hardware device that sends a ping and says, okay, the system is alive, the system is alive. Or you can have a soft watchdog that also sends that information in order to see that the system is still available and hasn't hung. And in my case, I've turned this off because I don't have that technology installed and I haven't looked into it. But I think it's a good thing to have in a production environment, but I don't need it for this case, so I turned it off. But you set it up here and it will pretty much read this device in order to see that the system is still taking or is still responsive. So that could be something good to look into. So if we quit out here, this is what we created on all the hosts as our Patroni config. And after that, you should of course run sudo u for the user, Postgres, Patroni, and then validate your config. So if you run this as the Postgres user and validate your config, you can see if you have any configuration issues. Currently, I have one configuration issue here. First off, I'm in a directory that is not allowed, but the other is that my Postgres server is still running on the host, and that is not allowed. So what I will do now is stop the Postgres server and disable Postgres, because we will not run Postgres as a service. We will run Patroni instead. So let's do that on all three hosts like this. So now we should be able to start Patroni. So what we do now for the post one, we will keep the database, but I want to initialize it for the other two hosts. So I will run this remove rf and then var lib postgres 15 main. There is the data dir. So I will delete that on host 2 and host 3. And then we will run some command for starting Patroni. And the important part here is that you want to start one host, verify that that host has started before you start the next host. Because if you don't do that, they can be hard for you to actually figure out which replica should be the leader and so on. So it's a good thing to start the system. So we will run system control enabled now, Patroni. We will restart Patroni, and then we will look at the journal for Patroni. So this should start up, figure out that there is a local host accepting connections, and then it will run no action. I am per one EI_org, the leader with the lock. So now we should be able to run the command Patroni ctl-c for the configuration file, list, and then we say the cluster that we have now. And if we run that, we see that we have one in this cluster called per one, and it's running and it's a leader. So now we will connect the second one, and we will run the same commands on that one. And when that has started and figured out that it's not the leader, we can go back here and run this command again. And now we see that it's creating a replica here. So it could take a little while. First it starts Postgres and the reacting connections. So it's waiting until it's accepting connections, and then it will replicate data over and then change over to the state as running. Let's do the last one here and run through a couple of commands. It should do the same as our second one. So let's see when it's done. Bootstrapping from leader. Now it's started. We see that it has no response. It's rejecting connections. And when the Postgres is up and running, it will do as it did in the other one, replicate over, and should now be running. So let's look again, and now we have the third one. So now our cluster is up and running, it's healthy, and we can use it. Let's add a little bit more to it. We need HAProxy as well to make it even more useful. And this could be put on all these 3 hosts, or you can put it on other hosts as well and have some failover there. So that is not covered here. I will just set up one HAProxy because I want to show you a very nifty feature of this one. So we will edit our HAProxy configuration here. And this is just the default configuration here for HTTP traffic. And I will add some more configuration here. So first I will add a block in the top here. Let's see, so we don't have any extra here. So we will have some listening for stats here, so we can actually see what is up and down in our system in a very nifty GUI. And then we will have one thing that we say is primary. So if you go to port 5000, you go to the primary host, and you should do it over TCP, and I use TCP log. If you don't use this, you get an error that says, yeah, HTTP is not the connection you are using. Then you want to have this option HTTP check primary, so it will connect to port 8008 and check if this is the primary host. And it will do that and expect the status of 200. And it will do that every 3 seconds. And if it has 3 failed connections, it will fall, and 2 good corrections, it will rise. And on markdown, shut down the sessions and so on. So max connections 100, check port, and so on. And the same goes for the standbys here. They will check the replica HTTP check. So this is interesting, and I will show you how it works. So first off, we of course want to run a verification on this. So we run HAProxy-c-f for file, and then we point out our configuration file. If we run that, we see that the configuration file is valid. So now we can reload our HAProxy. If we switch over to my browser here and go to that IP, let's see here, we had 168 was the new IP here, 68. So now we see a live view here of that we have pair 1 is up and running, and then pair 2 and 3 are our standbys. So that is a very cool view to see that we have the ability to connect to either the real services or the standby services. So if we go back here, I should be able to use my connection variable here. So we can go to open observe on port 5000 with my password of change me now. And if I look at if this is read only, so we can do this transaction read only, we see that it's not read only. So I'm able to write here, and I should be able to do select, go to the database, of course, open observe, and then select star from users. So I see the users there. If I go to 5001, same password again, and then check this transaction read only, it should say on now. So or if I now change over the database, observe, and then insert into users values 1 fail, shouldn't be able to do that. I can't do an insert on a read only transaction, but I can read things here, of course. So let's do a select instead from users. So I should be able to see the data. So if you have a setup where you're running a web application where you can distinguish from read and write write operations, you could use this in order to be able to have more usage of your databases, because you could use the read-only databases for more web calls of that nature. Often you don't write that much to a database, you read a lot from a database. So that is a very interesting use case. I have a couple of very good troubleshooting steps as well in my write-up later on. When I did this, I failed a bunch of times. You need to, of course, remove the databases if you want to restart, because they can end up in a very strange state. And I also have a command to use this Patroni control in order to remove a cluster, because when you want to start on, off again and reinitialize Patroni, you need to remove the cluster and so on. So I have a couple of those, and also if the Patroni cluster is in a bad state, the database can also be in recovery or be read-only, so you need to promote it in order to get it up and running and so on. But we can look at the Patroni control here again, because there is a couple of really good commands here. So if we do help, we can see here that we have two commands. One's called switchover to a replica, and another is failover. And failover pretty much throws a replica down and then promotes another one. So that could be something that you actually are losing some data, or you're losing connections and reliability might be less, but it's very quick failover if you really need to do that. But the more secure way is a switchover. So if we do a switchover here, switch over, and then we say for cluster 1. So that's how you are talking to it. You need to say which cluster. And here it first asks which is the primary. And we see that per one is the leader. So we will just say, okay, that's the one I want. And then which candidate do you want to switch over? So k2 ea org. And then it will say, when do you want to switch it over? So I can actually give it a particular date or time, switch over then or now. If I do now, it says, sure you want to switch over to the cluster to demoting the current leader? Yeah, I want to do that. And if I do that and then go over here, we see that the one goes down and then Perl 2 takes over, and then it switches over in the standby as well. So we can see that it's done in a fairly good manner, slowly, and in order to not lose any connections, and you can talk to the database all over the switch over. So this was what I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. Are you using Postgres in your production environment and are interested in this? Leave a comment in the comment section down below. If you have any other solution, leave a comment about that as well. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you want to support the channel, there is donation links and affiliate links in the description down below, and I really hope to see you in the next video.